Hello, in this lecture we will find the value of 2 times AP, or the size of 2 times AP. In the picture we have triangle ABC. Side AB of the triangle equals to 90 degrees to 90 units. The size of side AB of the triangle is 90 units. The size of side CB of the triangle is 50 units, and the size of side AC of the triangle equals to 70 units. Okay, and we have also a circle, and the center of the circle is in point P, and actually point P is situated in side AB of the triangle, and we also have 2 tangents to this circle. The first tangent to the circle, actually side AC is tangent to the circle at point, we will call that point O. Again, side AC is tangent to the circle at point O, or the touching point between side AC and the circle is at point O, and also side CB of the triangle is tangent to the circle at point, we will call that point E, or the touching point of side CB of the triangle with the circle is at point E, or side CB is tangent to the circle at point E, and side AC is tangent to the circle at point O. In the next step, we will connect points O and P together by a straight line. So actually line OP or line PO, it is the same, is the radius of the circle. I will call it R, abbreviation for radius. PO is the radius because it starts from the center of the circle, that is to say from point P, and the line PO ends at point O, that is a point on the circle. And for that reason, PO is the radius of this circle, because this is exactly the definition of radius of a circle. It starts from the center of the circle and it ends on any point in the circle. For that reason, PO is the radius of this circle, and we will also connect points P and E together by a straight line. And again, line PE, the straight line PE is the radius of the circle. I will call it R, because it starts from the center of the circle and ends at a point that is on the circle, that is to say point E. Okay, so we created 2 radiuses of this circle. Okay, and we actually have a rule that states that in any circle a radius and the tangent to that radius are perpendicular to each other. So the radius PO and the tangent AC to the radius are perpendicular to each other according to the rule that I mentioned. For that reason, angle POA equals to 90 degrees, and also angle POC equals to 90 degrees because PO is the radius of the circle and AC is the tangent to that radius. And according to the rule that I mentioned, in any circle a radius and the tangent to that radius are perpendicular to each other. So PO is perpendicular to AC. For that reason, angle POA equals to 90 degrees and also angle POC equals to 90 degrees. Okay, and in the same way, we can say that because of the fact that PE is the radius of this circle and CB is the tangent to that radius, therefore PE is perpendicular to CB. That is to say, angle PEC equals to 90 degrees and also angle PEB equals to 90 degrees. So I will write the rule number 1, I will write it down. The rule states that in any circle a radius and a tangent to that radius are perpendicular to each other. Okay, I will read it again. According to rule number 1 states that in any circle a radius and a tangent or the tangent to that radius are perpendicular to each other. So actually, if we have here a radius, I will call it R, and we have a tangent to that radius, I will call it T, then the radius and the tangent are perpendicular to each other. That is to say, this angle is 90 degrees and this angle is also equals to 90 degrees. Okay, again, in any circle a radius and the tangent to that radius are perpendicular to each other. Maybe we make a small correction. In any circle, a radius and the tangent to that radius, okay, it is a radius, and you have the tangent to that specific radius. So the radius and the tangent to that radius are perpendicular to each other. For that reason, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay, we have radius PO, and the tangent to this radius, AC is tangent to radius PO of this circle. For that reason, the radius is perpendicular to the tangent. That is to say, angle POA equals to 90 degrees, and also angle POC equals to 90 degrees. We have here radius PE and the tangent CB to that specific radius, and according to the rule, the radius is perpendicular to the tangent. So angle PEC equals to 90 degrees, and also angle PEB equals to 90 degrees. Okay, in the next step, we will draw a perpendicular to side AB of the triangle, and we will call the touching point between the perpendicular to the side AB of the triangle capital M. So from point C, we draw perpendicular to side AB of the triangle, and the touching point between the perpendicular to side AB of the triangle is point M. So CM is perpendicular to side AB of the triangle. For that reason, angle CMB is equals to 90 degrees, and also angle CMA equals to 90 degrees. Okay, we raised perpendicular from point C to side AB of the triangle. The touching point between the perpendicular to side AB of the triangle is at point M, and CM is perpendicular to AB. That is to say, CMB is equals to 90 degrees, and also angle CMA equals to 90 degrees. So we actually have here 4 right triangles. We created 4 right triangles because triangle AOP is right triangle because angle POA equals to 90 degrees, so triangle AOP is right triangle, and also triangle ACM is right triangle because angle AMC is 90 degrees. For that reason, triangle ACM is right triangle, and also triangle CMB is a right triangle because angle CMB equals to 90 degrees. And for that reason, triangle CMB is a right triangle. It is the third right triangle, and the fourth right triangle is triangle EPB. It is a right triangle because angle BEP equals to 90 degrees. For that reason, triangle PEB is a right triangle. So we have here 4 right triangles, and in the next step, we will define angle CAB of the. We will define angle CAB as alpha. Again, angle CAB or CAM equals to alpha, And we will also define angle CBA as beta. So angle CBA or CBP equals to beta, and angle CAB or CAP equals to alpha. Then we will define that AP equals to X. Then PB will be equal to AB minus AP. That is to say, PB equals to AB, that is 90, minus AP, that is X. So it is 90 minus X, so PB equals to 90 minus X. And then we will focus on the right triangle OPA, and we will also focus on the right triangle CMA. Okay, so we'll focus on those two right triangles, triangle AOP and triangle CMA. And actually, sinus alpha in triangle OPA, the right triangle OPA, equals to the ratio between the angle that is the ratio between the side that is in front and of angle alpha. The side of triangle OPA that is in front of angle alpha is actually OP. OP is in front of angle alpha. So we write it down. Divided by the hypotenuse of triangle OPA. And the hypotenuse of triangle OPA is actually AP. Okay, so it is AP is the hypotenuse of triangle OPA because actually side AO of triangle OPA is perpendicular to side OP of the triangle. So sides AO and OP are the perpendiculars of this right triangle. So AP is the hypotenuse of this right triangle. So sinus alpha equals to OP over AP, the angle that is in front of alpha, divided by the hypotenuse of the right triangle, that is to say OP over AP. And if we focus on the right triangle ACM, then sinus alpha equals to the side that is in front of angle alpha, that is to say CM, divided by the hypotenuse of triangle CMA, and the hypotenuse of triangle CMA is AC. Again, I will explain why AC or CA is the hypotenuse of triangle CMA, because the other sides of the triangle, side CM, is perpendicular to side MA of the triangle. So CM and AM are the perpendiculars of the right triangle. So the third side of the triangle must be the hypotenuse of the triangle. That is to say, AC is the hypotenuse of the right triangle ACM. Okay, so in total we got that sinus alpha equals to OP over AP equals to CM over AC. So we will copy this equality here and we will call the new equation equation 1 with this equality. Okay, so our first equation is actually OP over AP equals to CM over AC. Okay, our first equation is OP over AP equals to CM over AC. But we know that OP equals to R. I'll write it down. OP equals to R and AP equals to X according to our definition. AP equals to X. And also we know that AC equals to 70 units. It is given us in the question. So I write down that AC equals to 70 units. So we know that OP equals to R, AP equals to X, and AC equals to 70 units. So we can put this data in the first equation. We can substitute OP by R, AP by X, and AC by 70. Okay, we'll do it now. So in the first equation we substituted OP by R because OP equals to R. We substituted AP by X because AP equals to X. And we substituted AP by 70 because we substituted AC by 70 because AC equals to 70. Okay. Here we can divide both sides of the equation by CM. CM actually is the perpendicular to side AB of the triangle, so it must be a positive number. It can never be 0. So it is allowable to multiply both sides of the equation by CM. Okay, so we'll get that R over CM times 6 equals to 1 over 70. So we divided both sides of the equation by CM. R over X divided by CM equals to R over CM times X. And CM over 70 divided by CM equals to 1 over 70 because we have CM in the numerator and we have CM also in the denominator, so CM is cancelled. So we got that this expression cm is cancelled, so we left only with 1 over 70. Here we multiply both sides of the equation by x. Again, x equals to AP, it is a positive number, so it is allowable to multiply both sides of the equation by x because it can never be 0. So we get that R over Cm equals to x over 70. Okay, here we multiply both sides of the equation by x. Here we have R times x divided by x. So x divided by x equals to 1. X is cancelled, so we left only with R over Cm equals to x times 1 over 70 equals to x over 70. So this is our first equation, R over Cm equals to x over 70. Now we will move to beta and we'll focus on sinus beta, and also we'll focus on the right triangle PEB, and we will also focus on the right triangle CMB. So sinus beta in triangle EPB, in the right triangle EPB, equals to the side that is in front of angle beta, that is to say EP, over the hypotenuse of the right triangle EPB. And the hypotenuse of the right triangle EPB is actually PB. Why? Because actually in the right triangle EPB we have side PE that is perpendicular to side PB. So PE and PB are the perpendiculars of this right triangle, so PB must be the hypotenuse of this right triangle. So in total we got that sinus beta equals to EP over PB. The side that is in front of angle beta, that is to say EP, divided by the hypotenuse of this right triangle, that is to say PB. And now we will focus on the right triangle CMB. In this right triangle, sinus beta equals to the angle that is in front of angle beta, that is to say CM, or the side that is in front of angle beta, and the side that is in front of angle beta equals to CM divided by the hypotenuse of triangle CMB, and the hypotenuse of triangle CMB is CB. Why? Because actually side CM is perpendicular to side AB in triangle CM, in the right triangle CMB. So sides CM and MB are the perpendiculars of this right triangle. So CB must be the hypotenuse of the right triangle CMB. So in total we got that sinus beta equals to EP over PB, that equals to CM over CB. Now we'll copy this equality and we will call this equality the second equation. Okay, so the second equation will be EP over PB equals to CM over CB. So I copied this equality here and I called this equality our second equation. EP over PB equals to CM over CB. But we know that EP equals to R, the radius of the circle. EP equals to R. And PB equals to AB minus AP, that is to say 90 minus X. PB equals to 90 minus X. And CB is given us in the question. CB equals to 50 units. So I write here that CB equals to 50 units. Okay, so we know the values of EP, the value of PB, and the value of CB. So we can put the value in the question 1. Okay, so we'll do it now. So here, instead of EP, we substituted EP by R because EP equals to R. We substituted PB by 90 minus 6 because PB equals to 90 minus 6. And we substituted CB by 50 because CB equals to 50. Okay, so in the next step, we'll divide both sides of the equation by CM. I've already explained that it is allowable to divide both sides of the equation by CM because CM can never be 0. CM is the perpendicular to side AB of the triangle, so it must be a positive number. So we will divide both sides of the equation by CM. We'll get that R over CM 90 minus X equals to 1 over 50. So we divided both sides of this equation by CM. So R over 90 minus 6 divided by CM equals to R over 90 minus 6 times CM. And CM over 50 divided by CM, or CM divided by CM equals to 1. So CM is cancelled and we left with 1 over 50. In the next step, we'll multiply both sides of the equation by 90 minus 6. Again, it is allowable because 90 minus 6 must be a positive number because x is less than 90, so 90 minus 6 must be a positive number. It can never be 0, so it is allowable to multiply both sides of the equation by 90 minus 6, okay? So we multiplied both sides of the equation by 90 minus 6. So 90 minus 6 divided by 90 minus 6 is 1. 90 minus 6 is cancelled in this side of the equation, so we left only with R over Cm, and 1 over 50 times 90 minus 6 equals to 90 minus 6 over 50. Okay, so we have actually two expressions of R over Cm. This is the second equation with the expression of R over Cm, and we have also the first expression from the first equation of R over Cm. Okay, so we will write down the two expressions of R over Cm. So from the first equation we know that R over Cm equals to x over 70. As you can see here, the first equation states that R over Cm equals to x over 70, and from the second expression we know that R over Cm equals to 90 minus 6 over 50. So I copied the two expressions of R over Cm here, and now we'll create the third equation that states that R over Cm equals to R over Cm, okay. R over Cm equals to R over Cm. Now I will substitute R over Cm by the value of R over Cm in the first equation, and here I will substitute R over Cm by the value of R over Cm in the second equation. Okay. Again, I repeat that I substituted R over Cm by the value of R over Cm in the first equation, that is to say, instead of R over Cm, I wrote x over 70, because R over Cm equals to x over 70, and I substituted R over 70 this side of the equation by the value of R. I substituted R over Cm by the value of R over Cm in the second equation. That is to say, the value of R over Cm in the second equation equals to 90 minus 6 over 50. Okay? So R over Cm equals to x over 70, and here R over Cm equals to 90 minus 6 over 50. Okay. Now we will multiply both sides of the equation by 50. Okay, we multiply both sides of the equation by 50. 90 minus 6 times 50 divided by 50, or 50 divided by 50 equals to 1. So 50 is cancelled from this expression, and we left only 90 minus 6. And x over 70 times 50 equals to 50 times x over 70. Okay, now we'll multiply both sides of the equation by 70. We get that 70 so we multiply both sides of the equation by 70. 70 times 90 minus 6 equals to 70 times 90 minus 6, and 50x times 70 divided by 70 equals to 50x. The 70 is cancelled because we have 70 both in the numerator and in the numerator, and also we have 70 in the denominator, so 70 over 70 equals to 1. 70 is cancelled, and we left only with 50x, that equals to 70 times 90 minus 6. Now we will open the brackets in this side of the equation. Good. So we open the brackets. I made a mistake. Before that, we will divide both sides of the equation by 10. Okay, so we'll get that so we divided both sides of the equation. We divided both sides of the equation by 10. 50x divided by 10 equals to 5x, and 70 divided by 10 equals to 7 times 90 minus 6. Okay, now we will open the brackets in this side of the equation. We will get that so we open the brackets here. So 7 times 90 equals to 630. 7 times minus 6 equals to minus 7x. Now we will add 7x to both sides of the equation and get so we added 7x to both sides of the equations. 630 minus 7x plus 7x equals to 630, and 5x plus 7x equals to 12x. Here we will divide both sides of the equation by 6. So we divided both sides of the equation by 6. 12x divided by 6 equals to 2x, and 630 divided by 6 equals to 105. So we got that 2x equals to 105. But we know also, according to our definition, AP equals to x. Okay, so we create the fourth equation that states that AP equals to x. This is actually according to our definition. So if AP equals to x, 2 times AP equals to 2 times x. Okay. So we have here 2 times x, in the third equation the 2 times x equals to 105 from the other side, and in the fourth equation we have that 2 times x equals to 2 times AP. Now we will create the fifth equation by the combination. We'll combine equation 3 and 4 together with the value of 2 times x. So the fifth equation will be 2 times x equals to 105. That is from the third equation. And 2 times x also equals to 2 times AP. That is for the fourth equation. Okay, so we have two values for 2 times x. 2 times 6 from one side equals to 105 from the third equation. Okay, and also we know that 2 times 6 also equals to 2 times AP from the fourth equation. So we can add here that 2 times x also equals to 2 times AP. This is from the fourth equation. So we got the equality that states that 2 times AP equals to 105 units. Okay, we got to the equality that states that 2 times AP equals to 105 units. Okay, from the fifth equation we got the equality that 2 times AP equals to 105 units, or the value of 2 times AP is equal to 105 units, or the size of 2 times AP equals to 105 units. Okay, so now I will summarize the lecture. We actually wanted to find the value of 2 times AP, and as you can see from the picture, we have triangle ABC. The size of side AB of the triangle is 90 units. The size of side AC of the triangle is 70 units, and the size of side BC of the triangle is equals to 50 units. And we also have a circle. The center of this circle is point P, and point P is situated on side AB of the triangle. And also we have two tangents to this circle. The first tangent is AC, side AC of the triangle, and side AC of the triangle is tangent to the circle at point O, while side CB of the triangle is tangent to the circle at point E. So we actually connected points P and O together. And actually PO is the radius of the circle, and also we connected points P and E together, and actually PE is also the radius of this circle. And actually we have a rule that states, rule number 1, in any circle a radius and the tangent to that radius are perpendicular to each other. Okay, so a radius and the tangent to that radius are perpendicular to each other. So R is perpendicular to T. That is to say, this angle is 90 degrees and this angle also is 90 degrees. Okay, so we can implement this rule in our circle because the radius OP, we have tangent to the radius OP. So according to our rule, PO is perpendicular to AC. That is to say, POA equals to 90 degrees and also angle POC equals to 90 degrees. In the same way, actually the radius PE or side CB of the triangle is perpendicular to the radius PE, and according to rule number 1, PE is perpendicular to PB, to the tangent of the circle. That is to say, angle PEB equals to 90 degrees, and also angle PEC also equals to 90 degrees. Because in any circle, a radius and the perpendicular to this house, this radius, are in any circle, a radius and the tangent to that radius are perpendicular to each other. So PE, the radius, is perpendicular to the side CB. That is to say, angle PEB equals to 90 degrees and also angle PEC equals to 90 degrees. Okay, so we created here two right triangles. AOP is right triangle and also PEB is a right triangle, and we also draw perpendicular from point C to side AB of the triangle, and the touching point between the perpendicular and side AB of the triangle is point M. So CM is perpendicular to side AB of the triangle. That is to say, CMB equals to 90 degrees and also CMA equals to 90 degrees. So we created two more right triangles because CMA is a right triangle because angle CMA equals to 90 degrees, and also triangle CMB is a right triangle because angle CMB equals to 90 degrees. Okay, and we also defined angles CMB as alpha and angle CBA as beta. And we actually know, and then we focused on triangle AOP and the right triangle ACM. And in the right triangle AOP, sinus alpha equals to OP over AP, while in the right triangle ACM, sinus alpha equals to CM over AC. So in total we got the quality, the sinus alpha equals to OP over AP, that equals to CM over AC. We copied this equality and we called it equation 1, but we know that OP equals to R, AP equals to X according to our definition, so PB will be equal to 90 minus X. Okay, and also we know that AC equals to 70 units, so we put all the data in the first equation, and we got that r over cm equals to x over 70, and actually we got, okay, so the first from our first equation we got that r over cm equals to x over 70, and then we focused on angle beta on sinus beta. We focused on the right triangle EPB and also on the right triangle CMB, and we know that sinus beta in the right triangle EPB equals to EP over PB from one side, but if we look at the right triangle CMB, there sinus beta equals to CM over CB, so in total we got that sinus beta equals to EP over PB, that equals to CM over CB. So we copied this equality here and we called it equation number 2, that states that EP over PB equals to CM over CB, but we know that EP equals to R, PB equals to 90 minus X, and CB equals to 50 units. So we can put all this data in the second equation, and we got that R over CM equals to 90 minus X over 50. So we actually have two equations with the expression R over CM. From the first equation we got that R over CM equals to X over 70, and from the second equation we got that R over CM equals to 90 minus X over 50. So we created the third equation that states that R over CM equals to R over CM, and we substituted the expression R over CM in this side of the equation 3 by the value of R over CM from the first equation, that is to say X over 70, and then we substituted the value of R over CM by the value of R over CM from the second equation, that is to say 90 minus 6 over 50, and so we have the equation that X over 70 equals to 90 minus 6 over 50, and at the end we got to the equation 3 that states that 2 times AP equals to 105 units from one side, but we created the fourth equation that states that AP equals to X, and AP equals to X according to our definition. If AP equals to X, then 2 times AP equals to 2 times X. So here we can create the fifth equation for the value of 2 times AP, because 2 times AP equals to 105 units from the third equation. So we can write here that 2 times 6 equals to 105 units, but from the fourth equation we have already know that 2 times x equals to 2 times AP, so we can add in the fifth equation that 2 times 6 also equals to 2 times AP. So at the end we got in the fifth equation that 2 times x equals to 105 and also equals to 2 times AP. Or we got the equality that 2 times AP equals to 105 units. Okay, so the answer to our question is that 2 times AP equals to 105 units, or the value or the size of 2 times AP is 105 units. Okay, thank you very much.